Good evening, everyone. So today I will share my progress about my research topic. And in this week, I try to implement the XS3, but I found some the input and output problem about the system, and I try to figure that out. And hopefully, this problem can be fixed by the weekend. As the next step, I try to understand the paper, and I want to implement the algorithm in this paper. The paper is named the Low Time Complexity Budget Deadline Constraint Workflow Scheduling on Heterogeneous Resources. This paper wants to solve this kind of problem by using the utility computing environment. And the utility computing environment and the cloud computing environment are the main computing resources in the scientific application, because in the big data age, and more applications are used to run this kind of task in the utility computing and cloud computing. And this kind of computing resources can have the different kind of computing resources requirement, include the high performance computing resources and the low performance computing resources. We talk about the computing resources model, and sometimes we always need to meet some quality of service requirements. For example, sometimes we need to meet the deadline, or sometimes we need to meet the budget constraint. And in this paper, I want to solve the two constraints, which is the deadline and the budget at the same time. In other people's work, and when you want to schedule a task to computer resources, first you may need to do some the search based strategy, which is that you try different combinations of different tasks to computing resources. But this kind of task is to need a lot of computer resources. You need to compute all different combinations. And in this paper, the author just want to find a feasible solution which to meet the deadline and cost at the same time, which means that this paper does not do the optimization part. This paper just want to find a useful solution. So what's the scheduling problems? The scheduling problem is just to find a map function from the task to the computer resources, which is subject to several different kind of constraints. The first one is that we can assume that one processor is only execute one task at the same time. And also we can base on structure of the workflow, and we can have the precedency constraints, which mean that the children task should be executed after all his parents' tasks finished. And also we have some different kinds of quality of service parameters, just like the budget and the deadline constraints. And also the workflow can, in this paper, the workflow is treated as directed acyclic graph with the three tuple. The first one is the task and the second one is the age. And also in this paper, the author assumed that they have another information with the data information. So the data information is the data matrix, which record the data sets between the task pairs. So we can, based on this data sets information, we can calculate the computation cost between the task pairs. It means that you should move some data from task A to task B. Let's go to the details of the deadline budget constraint scaling algorithm. So the input is the structure of the workflow under the two users quality of service parameters, which is the deadline and the cost budget. So since the problem is try to meet the two constraints, so the idea is very simple. The author try to make sure that the budget should be made first. Then, under this constraint, and the author want to find some scheduling algorithm which can be finished before the deadline. So it means that even the budget constraint is met, so sometimes the deadline can be missed. So in this case, the author treated that the algorithm is failed. So in the experiment result, and the author used the successful rate to evaluate the performance of this scheduling algorithm. And let's go to the detail of the scheduling algorithm. So we have the three input. The first input is the structure of the workflow, and the second is the deadline constraint, and third one is the budget. So first, we need to calculate the cheapest cost. So what means the cheapest cost of the workflow? It means that all the tasks in this workflow should be assigned to the cheapest resources. And in this way, we can get the cheapest cost of this workflow. If this cost is bigger than the budget, it means that the budget is too small. We cannot finish the workflow, even use the cheapest community resources. And if the budget is bigger than this cheapest cost, so it means that we can have, so if we assign all the tasks to cheapest cost, cheapest resources, we can have some extra cost left. So we can use this extra cost left to update the community resources, and we can distribute this cost to some other community resources, and then we should calculate the upward rank. And in the previous algorithm, the ICP-SP, we always we use some other function to get the order of the tasks, and also we should calculate the sub-deadline for each task. And how to calculate the upper rank value? And here is a formula to how to calculate the upward rank value of the TI. So the formula is the communication cost between two tasks, and this task is the average value. So first, the term is average data latest value, and also the data communication cost is based on the data size and divided by the average bandwidth. And then we have the execution time of this task. And then we start from the existing task, and then we can calculate the parents of the existing task. Then we can recursive to calculate all the tasks upward rank value. After we finish this process, and we can get the order of all the execution tasks. It means that the highest value should be the first one to be executed, and the smallest value should be the last one to execute. And then for each task, we also can have a sub-deadline for each task. And how do we get the sub-deadline for each task? And we, based on this formula, it's the same formula that you can use to get the last finish time for each task. So we use the last finish time as the sub-deadline for each task. And then after the fifth step, and we also have the order of each task, and also we have a sub-deadline for each task. And then we can do the scheduling. And first we need to get the highest rank value, and then we need to schedule this task. So first we need to find all the admissible computer resources for each task. What's the admissible computer resources for this task? And first, we already have the extra cost, and then we can add the minimum cost of this task, and we can know its cost can be used to assign a computer resources. So it means that if the computer resources the cost of these computer resources is lesser than this value, it means that the computer resources is admissible, and then we can have a set of admissible computer resources. After we have this set computer resources, and we can calculate the quality measure, and then we base on this quality measure with the highest value, and we can assign the current task to this processor, and then we can update the extra cost. But why do we need to use this quality measure? And this quality measure is based on the two parts. The first part is the time, and the second part is the cost. So for the first term, so we have this omega here, and we also have the last finish time, and also we have the finish time. So if the last finish time is larger than the finish time, so it means that this task can be finished before the deadline. So the theta is equal to 1, and also its value is larger than 0. So if the deadline is smaller than the finish time, it means that this task cannot be finished before this deadline. So the value is negative. And based on this performance, we can see that the value is bigger, the better. And also, we have the cost. And the best cost of the current task is the cost with the earliest finish time. And the earliest finish time is based on the earliest start time and plus the execution time. So we can see that the cost of the current task in this processor. So this value, if this value is small, and then it should be better. Also, the cost is also larger. So it means that these two terms are larger, the better. So we should select the highest value for these two terms. So this is the whole idea of this Dbcs scaling algorithm, and this algorithm is used in the utility computing, and if we want to transfer this algorithm to the Arm EC2, and also for I only have I think for the process 8 we need to do some changing. First we need to select the which computer resources type is we need to be treated as a admissible computer resources, and then we can, based on this computer resources tab, and we can select the computer resources instance. So since the ARM EC2 is charged by hourly, so I don't have any better idea to how to formalize the cost. So maybe we can discuss it tomorrow. Yeah, thank you.